So you're new to C#, you're trying to figure out what everybody's talking about with clean architecture, you're wondering, how do I format my application? What does my application structure look like? So what I want to do today is go through a basic application structure and how you apply clean architecture to it and give you a basic breakdown of what that means. So first, let's take a look at clean architecture. So I have this basic diagram. A lot of times you'll see the circle or some other diagrams. I never really, when I was starting out, those didn't make a lot of sense to me, so I wanted to give you something that made a little more sense. So what clean architecture roughly boils down to is you have the center of your application. It has your business logic. Sometimes we refer to it as the main application. Sometimes you'll see it referred to as use cases, features, whatever they want to call it. The core of your application, this is where all of the brains of your application live, where everything that is going to happen, that functionality is in here. So this thing, it knows about nothing except for your models. So if you think about your application as structured into things that go in and out of it, and then it talking to other stuff, generally the only thing that passes between everything are your models. And so you might see them referred to as domain, you might see them referred to as models, but these are going to contain things like DTO, which stands for data transfer object. You may see them split up into request and response. You may see them split up into, well, request and response generally. So these things are passed between all three layers of this. I'm calling it layers. A lot of times I show it as a circle, but this is what makes more sense to me. So this doesn't know about anything. It doesn't care how it gets a request. It doesn't care what it passes it to. It knows, I get this thing in, I process it, I send it out. So you have generally either a web API or maybe some socket listeners. If you have a chat application, maybe you have both. These know about this, and so they will send a request to this, and your class, your method, is going to have a response. So they send a request into it, and then they get a response back. This doesn't know what's calling it. It doesn't care what's calling it. It just gets a request, sends back out a response. Now, it is going to talk to certain things. It's going to talk to probably a database. You might see referred to as a repository. It's going to talk to services, usually shared services, or they're usually referred to as shared services, sometimes referred to as infrastructure. There's various names they can have. But usually this is going to be things like email, it might be things like notifications. Sometimes shared services will be things like getting data from another API. It might be calling out to an API. It might be calling to a message bus if you have a PubSub style application. PubSub, if you don't know what that means, it basically means there's this piece of the application that you send a message to, and based on that message, whatever type it is, it's going to broadcast and say, hey, I got this. And anybody listening for that certain type of message is going to hear that signal, and it's going to do something based off of that message. So you'll see that a lot in maybe like a messaging app, like an app like Twitter. Twitter will get a new message that comes in. It might send it to the message bus. The bus will say, hey, I got a new message. Now, that might, one piece of the application may store that message in the database. One part of the application might send out a notification. And so there could be multiple steps along there. So a PubSub style application is one where one central thing gets something and then it broadcasts out that it got it, and anybody who's listening for that specific thing will do something. So that's a little bit extra on top of this. But So if I'm saying this thing doesn't know anything about what's calling it, but it's calling the repository, well, how does that work? How does it know it's calling this if you just said it doesn't know anything about anything? Well, in the application layer, you're going to have interfaces. If you don't know what an interface is a outline of a class and what methods it has in it. So for a database repository, you may have an interface that says the user repository has a get by ID, get by email, update, and delete. And so it doesn't care what you pass to it, because all it knows is that whatever you pass to it matches the interface. And so if it matches the interface, then it doesn't care what it is. And so, well, how does it know what to call? Well, so I'll show you once we get to that part. But essentially, you're going to say, hey, this class matches this interface, and so I'm going to register those in my application. So we'll talk about that. I'll show you what that looks like. So this is basically the breakdown of simple architecture. Sometimes people name things differently. I'm giving you the basics of it here. So all your logic, all your brains of your application sits in there. From the user, they'll come into either an API or a socket listener or maybe something else. They will call and get a response from that, and then this thing, based off of a interface, will talk to either a database or maybe shared services or maybe an email bus. And the only thing that's the same between all three of them are your domains or your models. So let's take a look at this in practice. All right, so I have a basic shell of an application here that I started a while back. I didn't really do anything with it. All I really did was implement authentication, which is a good place to show you. So let's talk about this. We have our domains. So like I said, the domain is the only part of the application that everything knows about. So in our domain, I have data transfer objects, so a login request object. Oh, I'm sorry, a login response. So this is what it's going to send back. And a user permission. And so this is a basic user permission that it's going to send back to the front end. So the front end, or it's also going to use it on the back end, so that the application knows what you have permissions to and what you're allowed to do. So you have your DTOs, you have your models, and these are going to match the database. These base models, they have to match the database. You can also have custom models and other stuff, but you're going to have a set of models that match the database exactly. And then you're going to have something like a wrapper. And a wrapper, in this instance, is an API response that takes a generic class. So I can basically, every API request is going to get back an API response. And that API response will hold a generic object. So I can say, hey, I'm going to send this API response back with this specific object. And I'll show you what that looks like. Okay, so we have our models. That's what gets passed and forth between the application. Let's look at our API next. Let's look at our API. So in our API, we have our controllers. A lot of times you're going to have a base API controller that you're going to want to have everything come from. Generally, what I do with my base API controller, I put my API version in there, and then every time a controller is instantiated, I grab the current logged in user. So I know, and this can be either from their session, it can be from a JOT if you're using a JSON file. This can come from a session, it can come from a JOT file. However you're doing authentication, I like to have a service which gets the current logged in user, and you can store that in a database. If you have a very large application, you can store that in memory if it's a small application. There's a lot of ways you can store that. And so I will generally have an auth class that it really does nothing besides get the current logged in user. It's going to pull that from memory. So it's not really interacting with any part of the database. It's just pulling the logged in user. If there's no logged in user, the user is null, or it's an empty user object. So what does our controller look like? So in this case, what you're going to see a lot is use of the mediator library. And so what mediator does is it kind of simplifies things. So this takes a login. Well, it takes a class which I've named login query. You can name sometimes if you break it out by command and query, you'll see them end in query. Sometimes you'll see them end in request. And so mediator says, hey, whatever type of object this is, I'm going to look for that class, and essentially it just links the class that it's calling by the name of the object that you have here. There's a little more to it, but at the basic level, that's what it does. And we'll take a look at that. What I'm also going to do is in my program file, I am going to, well, this is pretty empty right now because I haven't done much with it, but we will take a look here. So my controllers essentially do nothing but take the request and pass it on to the application. So let's take a look at the application. My application, here's all my interfaces. So let's talk about interfaces. I said we had some shared ones, like an email service. So see, I have an email interface that is going to have a send email method. The application doesn't care what class does that. And that's one of the benefits of this clean architecture, is the application defines how it interacts with things. And where that is good is because it allows you to swap out any single piece of the application because it has to match this interface. So let's say I'm connecting to Gmail. My application is small. I'm connecting directly to Gmail to send out my emails. I have an email service that I pass in, and it matches this interface. And so let's say my application grows and I want to use AWS Simple Messaging Service. I can plug in a new service and I don't have to change anything about my application because my new service will match this interface. The application doesn't care what it talks to because it has these defined interfaces that everything has to match. And so again, it allows me to swap out anything. So let's take a look at, a lot of times you'll have a generic repository. And it can be generic because I can say it takes a generic object. So let's take a look at my user repository interface. It is going to inherit from that generic repository, and all that means is that it implements everything that was in here. So this had a get by ID, add, update, and delete, but it uses this generic object. So in my user repository, I say, hey, implement all those with the user object. And then I can add in other ones that aren't going to be common to everything. So in this case, like a get by username for a login instance. So my application has all of my interfaces. It's going to have my auth service. Now, this service extensions. Well, in this case, all I'm really doing here is adding my AutoMapper stuff and adding my mediator. AutoMapper, we're not really going to get into it. It just means I have this class, I have this class. They're basically the same. Map this to this, and I can just call the AutoMapper, and it automatically converts it for me. So I only have to write that once, and I'll show you an instance where I'm doing that. Then I don't have to, I have a user, and I have a user, and I don't have to map those 10 times in my application. I map it once, I call AutoMapper. Some people don't like using AutoMapper, that's a whole discussion in and of itself. And so this is just basically saying, hey, this is using this. Now let's talk about features. So features, and I've seen these called actions, I've seen it called multiple things, but essentially I'm going to split them up by the domain of my application. So let's take auth. I have a query. If you're going to do CQRS, which is a whole nother topic, you're going to split up requests that come in by, are they writing to the database or are they reading from the database? And the reason you might split that up is because maybe you have a highly concurrent database to handle reads, and then you have a separate database that handles writes and then pushes updates to that read database. A whole nother topic. So let's take a look. This really is where all the guts of my application live. This is where all the logic happens. So let's take a look at my login query. Now remember I said this login query class. Well, it implements the iRequest object. Again, this is an interface. And so iRequest is from Mediator. So let me briefly go back to my auth controller. Remember I said my object that I'm expecting is the login query, but my login query implements the iRequest interface, which basically just allows me to call Mediator send query, and all that does is come in here and tell it to call the handle method. So and you don't have to implement Mediator. There's been times when I had to implement things where I didn't have Mediator or I couldn't use it, and you can basically kind of recreate this without the library. The library just makes it a little less code is all. So you can see my login query has properties of username and password. So then it's going to call this handle method, and I'm telling it, hey, look, I'm going to send you back an API response with a login request response DTO. So remember, interfaces again, I can, or in this case, generics, my API response, I tell it when I instantiate it what kind of object it's going to pass back. So basically, this right here, from here to here, this is all the logic. So I check, grab the user by username. If there's no user, I send them back an error. Hey, no user found. If they are found, then I double check and make sure the hashes match. Then I'm generally never going to send back salt or password with any request. You can put in things. You could potentially put in a include secret somewhere, but very few instances you're actually ever going to do that. So then here we go with my auto mapper. I map user permissions to I map what I got from the user to my user permissions DTO. So everything that matches, it's just gonna put it in. I tell it when it expires. I generate an auth token. I create my response and I send it back. So this is obviously a little bigger. There's other stuff that happens in here, and well, those are methods that this uses, and because all of my login authentication happens here, this is the only place that needs to live. Now, maybe I'm going to encrypt things a certain way. That's an instance where I might have a service, because that can be used in multiple places, like my auth service, where it grabs the current user. No, I'm sorry, my auth service will do things like handle my encryption. And so, but those are going to be very specialized. They're only going to do like generally one thing. Generally, everything is going to live in here. And so if you think about what goes in here, think about it like a request that a user would make. Maybe they're going to make a post to a group. Maybe they're going to update their profile. Whatever a user action would take, it's going to have its own encapsulated class that all the logic in there is going to have in it. Now, what about things like something that uses, or maybe it's functionality that's used across? It can be its own thing, but it can also be part of another. If that functionality has its own set of logic, because if it's just like updating a database table, well, I have my repositories. I can just update a database table from anywhere. I'm not duplicating code. I'm just calling an existing method. But if there's logic behind it, I might have a specific class for that. And if login needs to update that as part of it, like maybe I log something, maybe there's a log that happens in there, or I don't know, any type of thing that could be a sub piece of multiple others. If it has logic to it, I'm still going to put it in one of these, and I'm just going to call it as part of this. So let's take a look at what I have else in here. This generate token, that is for my JOT file. That's for my JOT token. Compute hash, that's just my encryption. Generate salt, that is if each password has its own salt, so this generates the salt. Verify password, and you can see here this calls the compute hash. Are the hashes equal? And then there's a whole method for that. And so these two are related to creating my JOT file. So this is the only place they're used. This is the only place they live. So everything is in here, and this is a lot of stuff to have in one. Generally, but these are kind of helper methods as part of this logic. If it starts to get into multiple things happening, that's a good indication to say, hey, maybe this stuff needs split up. But these are all related to the logic in here, so they live in here. Okay, so that is what the actual application does. It has my interfaces, it has mappings if I'm using AutoMapper, it has general services, and it has the guts of the actual application. So what haven't we talked about? Shared. So what lives in shared? Things like an email service. I don't know that I just kind of built in a sample one here. Like this is something if you were gonna use a Gmail account, which you generally wouldn't, but maybe it's a small application and you're just doing that. But let's say you're gonna send it through Gmail. There's a sample of what an email service might look like. It uses the email interface, so it implements send email. Now here is where I'm registering with the application. I'm saying, hey, this email service or this email interface, use this service when you call that. Same with the date time. And so let's go to my repository. So my repository, now up here in the app, we saw my interfaces for my repository. So in my repository project is where I keep my actual repository. So I got a couple of these built out for you to see. This is just a simple implementation, so it is using Entity Framework. And so I have my get ID by async. All these do, and get by username. All these do is get stuff in and out of the database. They have no logic built into them. You never want to put logic in here. There's generally no reason to ever put logic in your database layer. And here's why. What if you change out your database layer? You have to re-implement that logic somewhere else. Or maybe you have a bug somewhere. I have had to go and find bugs because logic was built into the database layer, and you're thinking, I'm looking through all this code, I don't see where this bug is being introduced. You look at your database layer, you find a little bit of logic in there, and it just causes problems. So anyway, ramped over, but In my repository, I have my database layer. So why do I have a service in my repository? It is simply because it gets my entity framework context. That's literally all it does. It checks if it's null, and it's giving me these because I wrote this back before some of the newer features were out. And so, hey, here's a handy thing about Rider. You've probably seen this before if you've ever used ReSharper in Visual Studio, but ReSharper is built by JetBrains and it's built into Rider. So it gives you these little code hints where you can say, hey, did you know you could just do that? And it will give you all this stuff. So essentially it's saying, hey, return that unless it's null. If it's null, return that. So that's literally all that service does. And that way, any one of these, because otherwise, when a request comes into the controller, that may need to do multiple things. It may need to update multiple tables in the database. I'm not going to create a new context for every repository, so I just have a context service, which on the user repository constructor, it just grabs the context. Okay, ignore that models. That was me messing around with stuff, cheating a little bit. Generally, you're not going to have that in here. You're only going to have your models in your domain project. So, what haven't we looked at? No, I think we did look at everything. So essentially, let's break it down one more time. Clean architecture is a way to separate the various concerns of the application. In my domain, all I have are models that get passed back and forth. In my repository, there's no business logic. There's just updating and selecting from the database. In my API, all I'm going to do is get the request, pass it to my application, get my response back, and pass it back to the front. And then in my application, I'm going to define my interfaces. I am going to, if you're using AutoMapper, you might have your mappings in there. You may have some basic services in there, but the majority of your logic is going to live in these. And that's pretty much it. So if you have any questions, post them in the comments below. This is not the be-all, end-all explanation of this architecture. This is an example of an implementation of it. There's honestly, you don't want to be so strict on it that you say this is literally the only implementation, because every application is different. And so while the broad strokes of it are always going to be the same, small differences in applications may require tweakings here and there. But the broad strokes of it are separate all of your concerns into separate projects. They don't talk to each other. They don't know about each other unless they have to. And that's basically it. Any questions? Give a comment below. Thanks.